Good afternoon. I am Shailendra, Assistant Professor in Department of Electronics and Communication Engineering. Today, I will discuss IC741 and its applications. IC741 actually is one of the most famous IC which is used for the operational amplifier purpose. As you can see, this is the 8-pin IC. These are the various pins. Pin number 1 is of offset null. Then pin number 2 is inverting input. Then pin number 3 is non-inverting input. Pin number 4 is V negative. Pin number 5 is offset null. 6 is used for the output. 7 is G plus and 8 is NC. So let us discuss these pins one by one. Before discussing offset null, I would like to discuss the simple pins like you can see here. As in previous lecture we have seen, IC 741 is for the operational amplifier purpose. In this operational amplifier, there will be two inputs. One will be the negative means inverting input, and another one will be the non-inverting input. And proper power supply is needed for this, like V plus and V minus and output. So to use this IC, if you want, first we should provide proper supplies like this V negative and V positive, so that operational amplifier IC can operate properly. And inverting input is this second number pin, and non-inverting input is third number pin, and this is the actually output, and this output will be taken from the pin number 6. And what is offset null? Actually, sometimes what happens, even though we are not applying any input, we can get output. This is due to the various reasons, like there may not be a perfect balancing between these two terminals, and generally it happens that it will provide some output. So to nullify, it will provide some output even though we are not applying any input. You may think, how does this voltage will come? We are not applying any input, but we are applying the power supply so that we can get some output voltage, and this output voltage is nothing but error, and this output voltage is called output offset voltage, and it should be 0. Offset voltage should be 0. Why it should be 0? It should be 0 because if we are not applying any input, that time output should be 0. So to nullify the output, we use these two, negative offset null and positive offset null. So now we have full idea about 7 pins. 8th pin is not connected into the this IC. It is not connected internally. This is the dummy pin. This is chosen just because for the standard 8-pin IC, we need to connect it dummy pin. This is the only reason. So you can see here that in case of IC741, you can use V plus and V minus power supply from 5 volt to 18 volt, whatever you want, you can choose depending on particular application. And pin number 6 is used to take output, and pin number 2 and 3, you know that we have already discussed. Even all pins we have discussed. And pin number 8 is not connected to any circuit. It is just a dummy lead to fill the void space in a standard 8-pin package. Now, if I will talk about the specifications of IC741, that means what are the various parameters that this standard IC will provide, like power supply. You can use minimum power supply of 5 volt and maximum power supply of 18 volt. It provides input impedance of about 2 mega ohms, which is very high, and output impedance of 75 ohm. Again, it is very low. Voltage gain is equal to 2 into 10 to the power 5 for low frequencies. As we know, that voltage gain is not a parameter that will remain constant for all the frequency ranges. So it will vary with respect to frequencies, but at low frequencies, its maximum value is 2 into 10 to the power 5. Maximum output current, it can provide 20 milliampere. Recommended output load is greater than 2 kilo ohm. Slew rate is 0.5 volt per microsecond. Actually, slew rate is the rate at which op-amp can detect voltage changes. Even we will discuss slew rate separate in the separate lecture. As we know that voltage amplifiers are those which amplify voltage, and better voltage amplifier will be that which can provide more input impedance and low output impedance. So as we have seen that in case of IC741, this operational amplifier provides very high input impedance and very low output impedance. So this is a near ideal voltage amplifier. Next, the characteristics of ideal operational amplifier. These, whatever we have discussed, are the practical characteristics of IC741, and for any operational amplifier, these parameters are desired ideally that we will discuss now. Like open loop gain should be infinity. Okay. Input resistance should be infinite. Ri should be infinite, or it should be as large as possible. And output impedance should be, output resistance should be small, it should be 0. Ideally, perfect balance. That means if we are not applying any input, we should not get any output. Next is 0 output voltage when input is 0. It is possible with the help of perfect balance only. And next is infinite bandwidth. That means this device should have a capability to amplify any signal from 0 to infinite hertz with equally. From 0 to infinite, this device should have a capability to amplify signals without any attenuation. Infinite common mode rejection ratio. It should have infinite slew rate and 0 drift of characteristics with temperature. That means characteristics of the operational amplifier should not change with respect to temperature. They should be independent of temperature. So these are the characteristics of operational amplifier. Few ideal characteristics and few practical characteristics we have seen, because to analyze any operational amplifier we must have idea about these parameters. Now to solve any circuit, there is one more important concept, that is of virtual short circuit. And you can see here that if I will consider operational amplifier, if this is voltage VA and this is voltage VB, even though you will connect it through any resistance like RF, even you can connect few more resistances. This is like V1, and then what will happen? VA should be equal to VB. This is called virtual short circuit. Equal voltages will be provided when there will be a short circuit. But you can see there is no short circuit even though these two voltages are equal. Due to this, the concept of virtual short circuit is there. Even though these two are not short circuited, and they are providing equal voltage. This is the reason why this is called virtual short circuit. If you will connect this to ground, in this case VA is equal to VB and VB in this case is equal to 0. So this time this voltage VA will also be equal to 0, and this is called virtual ground. And virtual ground concept we will use many times while solving various applications of operational amplifier. However, in previous lecture I have explained virtual short circuit briefly. Now next is voltage follower. As you know, I have already discussed inverting op-amp and non-inverting operational amplifier. In case of inverting operational amplifier, gain was equal to minus RF upon R1. And in case of non-inverting operational amplifier, gain was 1 plus RF upon R, where RF is the resistance which is connected in the feedback and R1 is the resistance which is connected near to the input voltage. So you can see here voltage follower. That means the device in which output voltage follows the input voltage. And how is it possible? If you will concentrate here, in this case AB is what? It is nothing but output voltage upon input voltage. And output voltage and input voltage can be equal if and only if the gain is equal to 1. And if you will concentrate here, in this case, gain can be 1 if RF is equal to 0 or Ri is equal to infinite. So this is the mathematical condition that must be fulfilled to design voltage follower circuit. That has been written here. Now we can one can ask a question that if the device is providing input and output voltage is same, then what is the use of this device? Actually, if you will see here, this voltage follower is providing output voltage equal to the input voltage. It is 100% correct. But there are few more applications of this circuit, like this device provides high input impedance. So for the impedance matching networks, we can use voltage follower. And you can see here, this is negative feedback. We have done this RF is equal to 0. So this is connected through simple wire, and in this case, output voltage will be equal to input voltage, and due to this reason, this is called voltage follower. Next is summing amplifier. As I already told you why operational amplifier is called operational amplifier. The reason is very simple, because this device can perform various options or various operations other than amplification, like it can perform adding, it can add inputs, it can subtract inputs. That means it can provide difference of two inputs. This device can provide differentiation. This device can provide integration. So these are the various applications of the operational amplifier. So first we are going to discuss summing amplifier. And summing amplifier are those which can provide output is equal to the summation of various inputs or proportional to the summation of various inputs. And you can see here very clearly that all like we have considered input 1, input 2, input 3. These are the various inputs which are, and all of them are connected to this inverting terminal. So due to this reason, this device is called inverting summer. So let us analyze this circuit. How does this circuit will work and what will be the output? If you will see here, let us consider current I1 is flowing in this resistor, current I2 is flowing in this resistor, and current I3 is flowing in this resistor. Okay. And by applying Kirchhoff's current law, you can see it very clearly that I1 will be equal to VI1 minus, let us consider this is voltage V1, VI1 minus V1 upon R1, I2 is equal to VI2 minus V1 upon R2, sorry, this is R1, and I3 is equal to VI3 minus V1 upon R3. And if you will apply Kirchhoff's current law at node 1, then by KCL, and we are considering here that IF current is flowing here and II current is flowing into the operational amplifier. Then by applying KCL, I1 plus I2 plus I3 is equal to IF plus II, and II will be equal to 0 because we have already seen that input impedance of operational amplifier is infinite, because Ri is equal to infinite. We should remember this. So now what we will have? We will have I1 plus I2 plus I3. I1 plus I2 plus I3 is equal to IF. And what is the value of IF? IF is equal to V1 minus V0 upon RF. And you can see here in all the currents, V1 is there, and why virtual short circuit, which we have discussed earlier, what will be the value of V1? V1 will be equal to 0 by virtual ground concept. Now you can put these values into this equation. If you will put these values and if you will solve, then you will find out that V output is equal to minus RF upon R1 VI1 plus RF upon R2 VI2 plus RF upon R3 VI3. That means output voltage is the inverted sum of scaled output voltages. That means V1 will be scaled by RF upon R1, VI2 will be scaled by RF upon R2, VI3 will be scaled by RF upon R3. Even if you want to remember it in another way, then you can remember. All of you remember the inverting operational amplifier. In case of inverting operational amplifier, output was equal to minus RF upon R1 multiplied by VI. In case of inverting op amp. So if you will apply this concept, then you will easily get this. One time you can consider VI1, then due to VI1 you will get this output. Due to Vi2, this will be the output. Due to Vi3, this will be the output and negative sign will be there. So you can solve it in any way. You will get the same answer, and that answer is this: V0 is equal to minus Rf upon R1 Vi1 plus Rf upon R2 Vi2 plus Rf upon R3 Vi3. So if you want that Vi2 should be 2 times, Vi3 should be 4 times, and Vi1 should remain as it is, and output should be the summation of these, then accordingly you can choose values of R1, R2 and R3. And if you want that it should provide the summation of various inputs without any amplification of individual inputs, then you can choose all resistances are equal. R1, R2, R3 is equal to Rs, the resistance which is connected into the feedback. That time what will happen, you will get this. If you will take these three as equal, if you will put Rs and Rf is equal, that means if you will consider R1 is equal to R2 is equal to R3 is equal to Rf, then you will simply get V0 is equal to minus V1 plus V2 plus Vi1 plus Vi2 plus Vi3. This. So this is how the operational amplifier circuit will work for the application of summing. That means if you want to use any operational amplifier that can provide simple summation, then you can choose all the resistances equal to some value and you can put into the circuit. It will provide you the summation of individual inputs. Here I am going to consider one example. Let us consider two signals. One signal Vi1 is equal to 2 cos omega naught t plus 25 t, and Vi2 is equal to 1.5 cos omega t minus 35 t. And these are the values of resistances. These are the power supplies. Now we have to find out the output voltage. As you know, in this case, these two resistances are equal. So R1 is equal to R2 and output voltage will be equal to, you can see here, you can apply this formula directly. And here it is nothing but we have generalized the relation for n number of inputs. Now you can see output voltage is equal to this, and now let us add these two, Vi1 and Vi2, because these are cosine waveforms and they have different phase shift. So we cannot add these two inputs simply. So how we can add? See here, we have converted it into polar form. And then rectangular form, and then we have added these two together, and again we have converted it into the polar form, and from that form we can use this relation. Okay, and you will get output is equal to minus 5.96 angle minus 0.285 degree. So if you will put it into the cosine form, you will get this as amplitude and this as this. So this is the actual output, and negative sign we are obtaining just because we are using the inverting case. That means we have applied various inputs. In this case, two inputs. We have applied both the inputs at inverting terminal. Due to this, negative sign is there. This negative sign is indicating that there will be a phase shift of 180 degree between input and output. So today we have discussed the basics of IC 741, which is used for the operational amplifier purpose. And after that we have discussed ideal characteristics, practical characteristics, voltage follower, and one application that is summing amplifier. In next lecture, we will discuss few more applications of operational amplifier. Thank you.